In this video, we will learn about electrovalency. So we know that ionic bonds are formed whenever the electrons get transferred from one atom to another. So the number of electrons that are lost or gained by an atom during the formation of ionic or electrovalent bond is called its electrovalency. So the atom which loses electron is called electropositive atom because it is acquiring positive charge, while the other combining atom which gains those electrons is called electronegative atom. So positive sign is placed before the valency of the electropositive atom, while negative sign is placed before the valency of electronegative element. So we know that in the formation of sodium chloride, so if I draw its Lewis dot structure, so sodium has 1 electron in the outermost shell, chlorine has 7. So this electron gets transferred to chlorine, which results in the formation of Na positive, and chlorine which has now 8 electrons with a negative charge. So if sodium is losing 1 electron, so the electrovalency will be +1, whereas chlorine is gaining that 1 electron, so the electrovalency of chlorine will be -1, and so on for other similarly for other compounds and other elements. Now what are the factors that favor the formation of ionic or electrovalent bond? So the formation of an ionic bond involves formation of cation by loss of electrons by one of the combining atom, then formation of anion by gain of electrons by the other atom, and holding of the positively charged cation and the negatively charged anion by electrostatic force of attraction. Therefore, the formation of ionic bond depends upon the following factors. First is ionization potential or ionization energy. So ionization energy is the energy required to remove the electron from the atom. So it is obvious that lesser the energy, more easier will be the removal of the electron from the atom, and thus cation will be readily formed, and this will result in greater chances of the formation of ionic bond. So we say lesser the ionization energy, more will be the tendency to form ionic bond. So we can say low ionization energy favors the formation of ionic bond. Metals which are of group 1, the alkali metals, and group 2 which are alkaline earth metals, they have low ionization energy. So they form ionic or electrovalent compounds. They can easily lose their electron. For example, we have sodium, which is an alkali metal, potassium, calcium, magnesium. So all these metals can easily lose electron because they have low ionization energies. Now the second factor is electron affinity. Electron affinity means the tendency of an element to attract the electrons towards itself, or here we can say greater the negative value of electron affinity, more will be the tendency of the atom to gain electron and form its anion. Because when an electron is added to an atom, energy is released, and when energy is released, we take it as negative. So if more energy is released means greater the negative value is there, so more will be the tendency of an atom to gain electron. So we can say high electron affinity favors the formation of ionic bond. Thus, one of the combining atoms should have low ionization energy and the other combining atom should have high electron affinity. And non-metals, especially group 17 elements which are halogens, they are characterized by high electron affinity values. Thus, they readily form ionic or electrovalent compounds with metals, especially alkali metals, alkaline earth metals, which have low ionization energies. Like we have chlorine, so it can readily form an ionic compound with sodium chloride because chlorine has high electron affinity, which is a halogen also. So in general, we can say bonds formed between the combining metals and non-metals are ionic. So one has to be a metal which will donate the electron, and one has to be a non-metal which will gain the electron to form ionic bond. Now let us study about the general characteristics of electrovalent compounds. Now the compounds which have ionic or electrovalent bonds in them are called ionic or electrovalent compounds. So some general characteristics are, first is the physical state. So ionic compounds are generally crystalline solids. They do not exist as molecules. Okay, there are not molecules, but they exist as a network of oppositely charged cations and anions in a closely packed structure. Each cation is surrounded by a definite number of anion and vice versa. For example, in sodium chloride, each sodium ion is surrounded by 6 chloride ions and each chloride ion is surrounded by 6 sodium ions. Here we can see in this structure. So ionic solids are somewhat hard because this structure, it is having strong forces of attraction between the oppositely charged ions. We know electrostatic forces are strong forces. So because of strong forces, these ions have a fixed position and they are generally solids, but the ionic solids are generally brittle and break into pieces when force is applied on them. Now the next is melting and boiling point. So ionic solids, they are characterized by high melting or boiling points, again because a considerable amount of heat is required to break the strong interionic forces of attraction which are present between the ions. Next is solubility. So ionic compounds, they are generally soluble in water and polar solvents. We know that like dissolves like. So ionic compounds or polar compounds, they dissolve in polar solvents. It is because of strong electrostatic interactions between the ions and polar molecules of the solvent. So we know that water is a polar molecule. Negative end of water dipole attracts the sodium ion. So here we can see this is a water dipole, means water is also polar. If I talk about water, so oxygen is more electronegative, so it has a partial negative charge, and hydrogen have partial positive charge. So this is water dipole which is having charge separation. Okay, charge separation. Now this is water dipole. So what happens is it will attract the negative end. We can see here the negative end of the water dipole. It is attracted towards the sodium ion and the positive end of the water dipole is attracted towards the chloride ion, and this is the ionic bond between them. So what happens is when these water molecules get attracted to sodium and chloride ions, so what happens is they will ultimately break the bond between sodium and chloride ion. The ions thus set free drift in water in all possible direction and the ionic solid gets dissolved in water. Here we can see ultimately the bond breaks and thus the solid dissolves in water. This is the same reason why conduction of electricity happens in aqueous state. See, ionic compounds, they do not conduct electricity in solid state because to conduct electricity, movement of ions is required. So we know that current is nothing but the movement of charge. So whenever the movement of ions happen, electricity gets conducted. But in solid state, we know although the ions are present, but they are not able to move towards oppositely charged electrode because they are held together by strong forces of attraction and rigid structure. But when ionic compounds, they are melted, means they are in their molten form, or they are dissolved in water, they conduct electricity. Because when melted or dissolved in water, the forces of attraction between the ions, they are broken and the ions acquire freedom of movement towards the oppositely charged electrons. This movement of ions towards the oppositely charged electrode causes the conduction of electricity, and this also forms the basis of the phenomena which is called electrolysis. So we can say ionic compounds are good conductors of electricity but in molten and aqueous state, not in solid state. So I hope this is clear to you. Thank you.